some operations. So I will tell you what are the different operations we can perform on the input images, something called as rotation. So I will rotate this input image in terms of anti-clockwise direction like this, or 180 direction like this, and another 45-degree direction like this. So for that, I will get so many other images with respect to the rotation. And one more operation is, you can say, blurring. And one more operation is shifting. So one more operation is, you can say, some kind of blacking nature with respect to somehow I need to attach some effective, if you can say effect, we already know it, some effective we're going to be you're going to be apply some filter kind of the effective nature in the input images. So we have these operation directly we can call by using OpenCV library. OpenCV is the very beautiful library for the you can say convolutional neural networks. Whenever you play around with the input images, you directly go and check out some of the predefined libraries for all the operations you're going to be perform. So whether you can also do some cropping for that matter to get more number of the images, some cropping and adding the grids, you can say adding the grids for each and every images you had. So you can do so many operations, I can say. These are some of the ideas we are going to be explored, but we have so many different operations we can also perform in the data loader step. So this data loader step is going to be given as 10,000 or maybe the 1 lakh images to train our model. So for that I will learn accuracy to get, instead of I'm getting some result around 0.7, I will get around maybe 0.86 like that, or maybe 0.9. So it will be helpful, I can say it will be helpful. Even we also going to be learn these things in the transfer learning techniques when we are going to be learn together. So that is the first step we are going to be learn, and some of the modeling techniques with respect to the preparing of your data sets, and also the modeling, applying the CNN model, fitting your model like hyperparameter tuning with respect to the learning rate what we learned yesterday, and some early stopping nature, evaluating your model, improving your model corresponding to whatever the hyperparameter tuning you have done. And also you can optimize your results with respect to the different optimizers, such as Adam is one of the best popular optimization technique. Some making predictions, showcase as input image and take your model, get some predictions. So you can also play around with maybe unseen data points at the time. So suppose you're going to be working with animal data sets. So at the time we discussed, so you can download from Google. If you go and Google, you will get all the images, right? Suppose I want to get a lion image. So lion images. So yeah, you can see so many images. Just download and play around with this so that you will get some unseen point data sets, right? So Google data sets are very important when compared to all the data sets. You can what you have to do, whenever you see an unseen data point, just play around with this unseen data point and try to get formatted with respect to the predictions, so that you will be familiar with this. I mean, whenever you require to do any kind of the modeling, you have to play around with the unseen data points corresponding, it's going to be giving as a good prediction, then you can productionize these models. So testing also one of the best example, I can say, whenever you productionize these models. So we can also call it as UAT environment for that model. So you can test by using any kind of the unseen data points. Currently tabular data sets we don't have any kind of the unseen data points, but images you can play around by using the Google images. That will a basic sanity check you have to perform every time. So yeah, so let's go this notebook. Yeah, so we have you can say we have some data set consist of the pizza related and also some fooding kind of the thing. So we need to classify some whether image is a pizza or not. So let's go and check out what are the different pizzas we had. So these are all images we had. These are so many images. You will also directly download from this link. Yeah, this link. Storage APIs, under this you will get the all. This is zip file. It will directly load it whenever you call this link. Okay, so let's go and check what is sample image. How does that going to be looks like? So you can see we are just imported as a matplotlib. Okay, matplotlib consists of the image, MP image, we can call it as. So we are just importing that image and to read that image. This is a very simple operation. You will also get it from the OpenCV. So if I type the OpenCV image read, so this is also very important to practice maybe in terms of the documentation perspective. So we have learned the scikit-learn implementations, TensorFlow implementation. So OpenCV is more popular for image kind of the data sets. You can learn these things much better. So even matplotlib is also going to be helpful, but what will happen, some of the cases we cannot use matplotlib because we cannot have that much of operation what we learn to represent as a data loading part. So for that, you can use OpenCV. Yeah, this is a sample image. We need to classify this is a stick or this is a pizza kind of the thing. So for that, you can see, yeah, you can see this is kind of conversion of your array, whatever the input image we had. You can see the size also going to be whatever we discussed, width, height, and also the coloring nature. What we have to do, you have to be normalize this. Yeah. Normalizing means whenever have RGB image, if suppose you have RGB image, so I will need to normalize. That means I'm just going to be divide by using 255. So whatever the value, it's going to be converted into the if suppose I have a value around 700, so it's going to be divided with this. You will get the value between the 255 0 to 250. So whoever the value, it comes under the 0 to 55, it comes under the grayscale image. So like that, we can also apply the direct grayscale function we have. You can see we just applying the 255 image, whatever the different images we had. So it's converted into somewhat format between the range. Yeah, so these are the some you can say some standard step we can follow for the you can say image data sets. So yeah, firstly you have to take the input images. You have to make some kind of the targets. So some of the cases what will happen, you have an image but you don't have the labeling kind of the nature. So this is somehow we can also get the data set by using bounding boxes. If you're aware of the some of the bounding boxes, that is fine. So I mean bounding boxes is nothing but whenever you have some of the image kind of the person kind of the thing, we are going to be draw a bounding box according to the person, according to some other objective. So this bounding box consists of the labels actually. This kind of the label one and label two kind of the nature. So for that we have also automated tools. I can say we have some automated and manual work and we can also do with respect to the different tools they have implemented. So you will get it from market whenever you learn some of the computer vision related data annotation kind of the things. So yeah, so that you will get the labels according to that. So many companies are spending a lot of the time and also the efforts to get the labels actually. So we cannot get that much of easy kind of the labels for all the images. Suppose you have 100 million images, so how to get the labels for this? So for this we have automated tools. So they have implemented actually, we can use directly. This is a paid software, I can say, not the free available software. So you will get the input images with respect to the targets what you had. According to that, you can construct your first layer or the input layer with respect to the convolutional layer what you had. You can specify like this. Okay, whenever you want to be specify any kind of the convolutional layer, you can specify the batch size, how many images you're going to be passed. And second is the input height and width and also the channels RGB colors. So at the time you mentioned with respect to the input size and also the batch size, then you can pass your convolutional layer. So convolutional layer consists of the some kerneling nature, then it's going to be learn some of the patterns according to that. So yeah, this is come from the TensorFlow. You can see TensorFlow got convolutional XD. So XD is nothing but we have 1D 2D, 3D kind of the thing. So what is the basic difference between the conventional 1D? We can also call it as a convent 2D and convent 3D. So the basic difference is the size. So somewhat, I think 1D having a small size when compared to the 2D like that. So it has some you can say some limit, you can say some limitation, or you can say sizing limitation, you can say size limitation with respect to the 1D and also the 2D with respect to the 3D. So most probably we can use to play around with 1D, 2D. If not, it's going to be work out with the 3D. So, and also you can apply with some of the hidden layers you want to be specified, like any kind of the dense layers or max pool layer, fully connected layer. And also you can specify different layers we discussed in the RNN section also. So that you will get somehow to learn training of the mechanisms iteratively in your hidden layers, to learn your weights and also computing the